Fourth in a series, looking at 2 sine x squared plus 2 cosine x squared equals 3. When I see problems like this in the book, I think somebody made a mistake, because I'm supposed to be stating which ones are identity and which ones are conditional. And let's see if this applies to either one of those two terms. Because the first point here shows me 2 sine x squared plus 2 cosine x squared to be 0 plus 2. And I tend to think this might be both the highest and lowest point in the sine and the cosine function. It's when you put 0 in. So I'm getting a big 2 over here. Let's see what happens when we add a little bit at a time. Let's watch the points run across this. I think I've talked about how to create tables inside Excel. It's probably part of the big points. We can do trig in here. We can do just about anything. So the first point, and I like this big long look at point number 1, from 0 to 1, or point 1 and point 2 in each one of the lines. You can see this long, the drop. The red represents cosine, and it drops here from the original 2 down to about 0.8. And then we see the sine rising. Well, let's put another one in. See the bend. But notice what's going on. It looks like the plus sign, combining the two, that by y so far remains at 2. So adding this point plus this point, the sine and the cosine together, ends up to be 2. Adding these 2 points together, adding this roughly 0.62 to about, it's reflective of both points, to about another 0.13, and it comes up to be, wow, 2. Interesting. Okay, let's do another one. Okay, they crossed at 1, and 1 also shows 2, but also these points added together. Yeah, 0.69 plus 1.3 and some odd digits. You can do the math, but they add it roughly to be 2, and it shows that here. Let's go ahead and go 2 more. Puts us a quarter turn around. Makes a big kind of a fancy X. Where have I seen that before? But there you go. Still 2. Looks like 2 is matching across, but what I'm looking for is to equal 3. Something's amiss. Maybe a mistake in the book, because I can answer both of the questions so far, unless there's something that's going to happen really funny halfway through, and it could, because it doesn't have to be a balanced look, as we saw in the last the last lesson. It tended to change. Well, the lesson before that, that's question 3. It tended to change shapes along the way. Okay, so I added that in. So presently, I'm almost, let's add this one in. That makes me halfway around. So at the quarter point and the half point, everything for the combining together of these 2 waves equals 2. Let's jump down again. And go ahead and finish out that double the pi, if you will. So this is pi times 4. Beautiful waves. Cosine seems just to be going opposite of each other in the flow, doubling each other's intensity. Everything's sounding at 2. Pretty cool. One last time. A pattern that repeats itself on and again. Good way of looking at functions. And I can say this is definitely not an identity. It would be if I changed this to 2. And it's definitely not an equation that's true all the time. Matter of fact, from the math, it's never true. That's it.